research design encompasses both the methodology and the procedures that are employed to conduct scientific inquiry. So essentially, a research design is, you can think of it as the glue that holds your research project together. Essentially, it structures the research and it shows how all of the major parts of your research project, the sample, your data collection measures, everything works together to try to answer your central research questions. So in this presentation, I'm going to talk about the main types of quantitative research designs. So I'm not going to make you read the chapters about them unless you're very interested. They'll be in the supplemental part of Blackboard because I'm just worried that you'll never get enough time to both read and listen to this. So this presentation refers to the Macmillan chapters that are in the supplemental section of Blackboard, but you don't have to read them unless this doesn't make sense or unless you have time to do so. But it's important content to cover, so I think I'm just going to do a presentation about it and not require you to read the chapters unless you have time. So in terms of the major types of quantitative research designs, you can think of them as being either non-experimental or experimental. And there are three major types of non-experimental designs: descriptive, correlational, and comparative. And then there are experimental research designs as well as quasi-experimental research designs. So I'm going to define each of those types and give you some examples in this presentation. Okay, so first of all, descriptive quantitative research designs. Essentially, those answer the question, what is or what was? So you can investigate the way things are currently or the way things were in the past. Cross-sectional refers to the idea that you're studying one point in time. So it could be today you want to see maybe what do students think about academic advising at ASU today? Or you could say, what do students think about academic advising at ASU 10 years ago? Cross-sectional refers to just when you're studying one point in time, either currently or in the past. And then longitudinal is studying people's views over time. So how did students think about academic advising over the past decade? So that would be longitudinal, right, over the past decade. But cross-sectional refers to just one point in time. But essentially it answers the question, what is or what was? So here are some other examples. So maybe, what is the current attrition rate from first year to second year at ASU? So how would you study that? Maybe just collect student records for all first year students who started in fall 2012, and then see how many didn't enroll then in fall 2013. So see the attrition rate, right, using student records. Another descriptive question, what has the attrition rate from first to second year been for ASU students over the past decade? Again, that would be a longitudinal descriptive question, while this one would just be cross-sectional, looking at the current rate. So this, to study this longitudinal question, you could just look at the trend of first-year students' likelihood of re-enrolling each semester over the past 10 years, right? So both of those are descriptive because they answer the question, what is or what was, just describing the current state of things or the past state of things. I put an example of a descriptive study on Blackboard. You don't need to read it. It's in the supplemental section. But essentially what these researchers did was they were interested in understanding cheating behavior among college students. So the research questions that they looked at were what types of behaviors do students engage in when they're cheating, and how do they go about cheating? And so to answer that question, it was really interesting. They collected actually discarded cheat sheets from a college classroom building, and then they looked at those to try to describe the current state of cheating behaviors at their college. So that example is up on Blackboard if you're interested in seeing an example of a published descriptive quantitative study. Another type of non-experimental quantitative research design is a comparative research design. So the way, as that word comparative suggests, comparative research looks at differences between two or more groups. So basically relationships. So a couple of different research questions that someone could look at would be, first of all, are there differences in male and female student experiences with academic advising? So here, still using descriptive data, like the prior question, but in this case, we're just comparing maybe males to females and seeing if there are any differences. And then another question could be, how does the attrition rate from first to second year at ASU vary according to students' racial or ethnic background? So here we were just comparing males to females, but here maybe we'll be comparing white students to African American students, to Asian students, to Latino students, something like that. So just comparing to see if there are differences between groups. But we're not saying, this is important, we're not saying that there's any causal reason that there would be these differences. So we're not saying that being male might cause students to have different experiences with their academic advisors or females to have different experiences with their academic advisors. We just want to know if there are differences in those students' experiences. So that's really important. Comparative designs are just looking at whether or not there are differences or how those differences exist. They're not saying, does being male cause students to have differences in experiences with academic advising, right? So just looking at whether or not there are differences. Comparative, right? Okay, so while comparative designs compare two or more groups on a variable, correlational research designs are a little bit different. They look at the relationship or the association between two or more variables. So they can either be bivariate, which is the relationship between two variables, or they can be multivariate, which can also be predictive, and you use this technique called regression. And that's a little technical right now, but don't worry about it right now. But what's important to know is that correlational research designs don't just compare groups on a variable, but instead they look at the relationships between two or more variables. So what does that look like in terms of research questions? So exactly this. So you could, first of all, an example of a correlational research question would be, what is the relationship between SAT scores and current attrition rate from first to second year at ASU? So what you do is you go collect information from student records maybe on their SAT scores, and then look at the relationship between SAT score and attrition rates. So you could calculate what's called a correlation to look at that relationship, a correlation statistic. And then I'll talk a little bit more about what correlations are and how to calculate them in another presentation, but it's just important to know that correlational research designs look at relationships between variables. Another example of a correlational research question would be, what predicts whether students who are admitted to ASU will actually enroll in a degree program here? So this study is actually done at universities all the time. Those of you in admissions would probably be familiar with this question in terms of how to manage your yield, right? So the proportion of students who are actually admitted who then actually enroll are called a university's yield. And that's really important and has ripple effects on a university, because if you anticipate that a lot of your students who are admitted will enroll and then they don't, so financially you won't get the tuition dollars you were expecting, and that has a lot of implications for capacity too. Even when your yield rate is higher than what you anticipate, then your classes, maybe you won't have enough class sections for the number of students, maybe you won't have enough space in your dormitory, etc. So this is something that universities actually study all the time, trying to predict who is admitted and who will actually enroll. And so it involves calculating the correlations among several different variables that are related to enrollment. So some of the common variables that universities use to try to understand and predict enrollment are maybe high school rank, maybe legacy status, like if parents went to the same university, so the student's state or their county of residence, their family income, all of those variables can predict whether or not someone will enroll in a degree program who's been admitted. So one of the important things, as with comparative designs, is that in correlational research, you can't really make any causal conclusions. We're isolating relationships, but we're not saying we know exactly what's causing students to enroll. We just are trying to predict, right, or looking at the relationships between different characteristics and enrollment. But we're not trying to say we know what causes students to enroll. So for instance, maybe we find a relationship between income and enrollment, like applicants who have higher family incomes are more likely to enroll at ASU. But we really can't necessarily say that income causes someone to be more likely to enroll. Because maybe it's not their family income that's directly causing them to be able to enroll in afford college. Maybe it's instead that the fact that they're in wealthier families means that they attended wealthier high schools and they were exposed to a culture that values earning a college degree. So it's not necessarily maybe the money per se and the income and the ability to afford college, but maybe instead it's culture. But maybe you don't have a variable that you're looking at in your research design that actually measures that culture. And so family income is actually representing it, or it's proxying it. That's what's called a third variable problem. It's a little complex and convoluted, but the important thing to know is that correlation does not equal causation. So you need to be really careful when you're phrasing your research questions and phrasing your conclusions from whatever study that you're doing. Anytime you have a non-experimental research design, you cannot make any causal conclusion. You can make conclusions that there are relationships that exist and you can predict things, but you can't necessarily say that something's causing something else. I have another real quick higher ed example of predictive correlational study. So I just think it's really interesting. And you can see that these kinds of studies have value even if you can't necessarily make causal conclusions. So apparently the average Facebook user has more than 150 likes on their page. And so some researchers collected that information and they found that the more you know about what someone likes on Facebook, you can really accurately predict a lot of other social categories. So from Facebook likes, you can predict with 93% accuracy what someone's gender is, and with 95% accuracy what someone's race is. So for instance, males are very, very, very likely to have liked ESPN on Facebook, as well as Band of Brothers, which is a band, Star Trek, X Games, Bruce Lee. These are the most common likes on Facebook that predict gender. And then also among females, here are some of their common likes. So kind of interesting, right? And African Americans and Caucasians. Another sort of something that I thought was interesting related to that, you can also predict IQ, only with 39% accuracy, but still interesting. So people who have high IQs are much more likely to like thunderstorms, which is a little odd. I don't know, whatever. The Colbert Report. But those who have lower IQs are more likely to like Sephora, which is funny because I actually I don't like it on Facebook, but I like Sephora. Anyways, you can also predict pretty accurately whether or not someone is liberal versus conservative according to their likes on Facebook. And so even though you can't make causal conclusions, so you can't say, liking Oklahoma State University causes someone to be conservative, but we do see a really strong relationship between those two dimensions of someone's social identity. Another another way that correlational study designs are useful is in baseball, right? The book Moneyball and the movie Moneyball shows how knowing more about baseball players' behaviors can predict their performance on the field and predict whether or not they'll help a team to win. So these kinds of research designs are really interesting and can be kind of give us a lot of information about the social world, even though, again, we need to be careful not to make any causal conclusions about these relationships that we observe. Let's say you actually want to determine a cause and effect relationship between one variable and another. So what you need to do is design your study to be experimental or quasi-experimental. And I'll explain exactly what that means right now in this presentation. But again, everything comes from your research questions, right? So if your research question, if you're really interested in knowing, does living on campus, for instance, cause college students to persist at higher rates than living off campus, you'd need to design an experiment. Just to make sure everybody's clear about the difference between an experimental research question and a descriptive or non-experimental research question. So you might also ask, if you were just interested in comparing the persistence rates of on-campus students and off-campus students, you could just ask a comparative research question, right? So what's the persistence rate of an on-campus college students? of on-campus college students compared to off-campus college students. That would just be a comparative, non-experimental design. And so you just collect data to see what's the persistence rate of on-campus students and then what's the persistence rate of on-campus students. But if you just collected that and compared those two rates, you wouldn't be able to make any sort of causal conclusion. You'd have to do that, you have to design an experiment. In terms of another way you could get at this same idea, a correlational research question would look at the relationship between living off campus and persistence rate. So looking at the correlation or the relationship between those two variables. But again, a correlational research design would not allow you to get at that idea of causality. So there are a few extra design elements you need to add if you actually want to make causal conclusions about relationships. And so I'll get at that logic right now. Okay, so the first thing that you want to do when you're actually doing a true experiment is that you need to randomly assign your participants to different groups in your study. So essentially what that means is that once you have your sample, and this is different from randomly sampling, okay? Random assignment in the context of an experiment is different from randomly sampling. And if this doesn't make sense to you, make sure to ask me about it in class. But the idea of random assignment in an experiment is that you'll randomly assign your participants to either a control group or your treatment groups. So let's go back to the example of living on or off campus. So what you do is you randomly, let's say you have 100 study participants, you'd randomly split them in half and say 50 of you are going to live on campus and 50 of you are off campus. Randomly. You couldn't say, hey, could 50 people volunteer to live off campus? No. Because the idea is that you want both of the groups to be equivalent, and the only reason why they would be different is by chance. So you've randomly assigned them. Random. Important. Then what you do is you want to pre-test on your dependent variable. What does that mean? That essentially means you need a starting point on whatever your outcome is, like their baseline knowledge. And then you can compare it to their knowledge or sort of what they're doing after you introduce your intervention or your treatment effect, whatever your experimental condition is. So in the persistence example, that's not as important because everybody's starting out in the same place on their dependent variable, right? So everybody's starting out being enrolled at ASU or being enrolled in college. So your pretest, you could pretest everybody and be like, hey, so are you enrolled? And hopefully everybody in your study would say yes, because everybody should be starting out at the same point. But it could be different in certain cases. So let's say you're interested in whether living on campus causes students to visit the rec center more often. So in that case, you'd first randomly say, okay, 50 of you are going to live on campus, 50 of you are going to live off campus. But then you give everybody in your study a pretest on how often they use the rec center, because you want to have a baseline idea of where they're at before they start living on or off campus, right? And then third, you manipulate your independent variable, and essentially that is introducing your condition of interest. So that is actually saying, okay, everybody, here's your living assignments, so actually go there and live on campus or live off campus. And then finally, after the period that you're interested in studying, then you'll post-test your participants on your dependent variable. So in the example of living on campus or off campus persistence rates, you would see maybe after the course of a semester or a year, you would collect information on everybody, whether or not everybody's still enrolled at ASU, and then you compare your group of students who lived on campus to your group of students who lived off campus and see whether or not that rate was different after your study is over, after the period of time that you defined as being your experimental conditions were concluded. So the thing is, though, if you haven't already figured this out from my explanation of what you have to do when you're designing an experiment, is that we don't really have that much experimentation going on in higher education. Only about 1% of all higher education research published in top journals actually used experimental design. I put an example in the supplemental section of Blackboard of one of those experimental studies. So it was basically a study that looked at the effects of exposure to racial diversity on college students' complex thinking. And so it was a study that was actually used as part of the arguments in favor of continuing affirmative action practices in universities, because the study was able to say we can prove from the study that exposure to diversity, racial and ethnic diversity, causes students to have more openness and complexity of thinking. It's actually, there are a lot of other flaws to the study design, but it is an experiment technically. But the issue in general in higher education is that it's really tough to randomly assign college students to experimental and treatment and control groups, right? You're not going to find a lot of college students who will go along with randomly being assigned to live on campus or off campus. It's tough. Or even randomly assigning them to college majors, right? Or randomly assigning them to, all different things. Randomly assigning them to playing sports or not. It isn't practical in practice. And so we don't have too many experimental designs in higher education. So even though we don't necessarily have true experiments in higher education, we use some of the design elements of experiments to strengthen the conclusions we can make about our phenomena of interest, and that's called quasi-experimental design. Essentially, it's a study that doesn't have random assignment or it doesn't have a pretest, but it still approximates an experimental design. So it's not quite as good as a true experiment. So one example is, I put the article again on the supplemental section of Blackboard, but it's a study that used a pretest and a post-test, but they didn't have a control group. Essentially what it was an alcohol program, and the researchers worked in a judicial office at a university, and they had a bunch of students who had been sanctioned for alcohol issues, and they decided to try out this treatment program, telling students about the dangers of alcohol. So what they did is they took all of the students who got caught with alcohol. They gave them a pretest about the likelihood that they were drinking. Then they had the students all go through the program. Then they gave students a post-test on how often they were using alcohol after the program. So again, there was no control group. So if they had split the students in half and only given half of them the alcohol treatment, or the alcohol program, that would have been a true experiment. But instead, they didn't have a control group. They still used a pretest and the post-test. So that's considered to be a quasi-experimental because they didn't have a control group. Essentially, another design that's similar is called a non-equivalent groups design. So that's when there's both a pretest and a post-test as well as a control group, but people opted into the control group or out of the control group. So using the example of the alcohol program, so let's say half of the students decided, okay, hey, yeah, I'll go through this alcohol program, and half of them decided, no, I'd rather pay a fine. So that wouldn't be random assignment because the students would be given the choice to either take the program or pay the fine, but it still would be trying to get at the idea, well, is there some relationship between this alcohol intervention, and likelihood of drinking again? You could also, another type of quasi-experimental design is if the researchers hadn't administered a pretest, so they didn't know students' frequency of drinking before they assigned them to be part of the alcohol intervention group or not, but they still used a control group and randomly assigned half of the students to be in get the alcohol intervention treatment and half of them didn't, and then they administered a post-test to see whether or not those two groups differed in terms of the likelihood of drinking. So quasi-experimental designs, essentially the idea is that you don't have a control group, or you don't have random assignment, or you don't have a pretest, but you still have other elements of experimental design that help you to make stronger conclusions about the likelihood of causality in a relationship. I'm going to just go through a few actual examples of both non-experimental, quasi-experimental, and experimental designs just to illustrate the differences in practice. So let's say if an admissions officer, she decided she wanted to see whether or not there was a relationship between taking a campus tour and prospective students' views about her university, so taking a tour. So what she wanted to do was mail out a survey to prospective students, and she asked them, hey, have you taken a tour? And then B, what are your views of our university, from negative to neutral to positive? So what would that design be? What type of research design, quantitative research design, would this be? So it would be correlational. It would be correlational because, again, that idea of she's interested in seeing whether there's a relationship, right? Relationship between taking a campus tour and prospective students' views about the university. So all she did was send out one survey, and she was going to look at the relationship between whether or not students took a tour and their university views of the university. So that's correlational. That's a correlational design relationship. What if she decided she wants to see whether or not a campus tour changes prospective students' views about her university? So before the tour, she gives everybody a short survey to measure their perceptions, and then she administers the same survey to tour participants afterwards. So the question that the admissions officer is interested in is she actually does want to get whether or not there's a causal relationship, right? Whether or not the campus tour is the actual thing that changes students' views about our university. But the problem is that she doesn't have a control group, right? So she hasn't split her group of prospective students into a treatment versus a control. Some are going to take the tour, some aren't, but she did administer a pretest. So that would be a quasi-experiment, right? So she has one group, but she gave them a pretest and a post-test. So that's a quasi-experimental design. She doesn't have random assignment in place. She's letting everybody who wants to take the tour take it, but she is using a pretest and a post-test, which is good. What about whether she really does want to get at that experimental idea? And so how could she go about designing a true experiment? So what she would do, the admissions officer, to do a true experiment, if she wanted to see whether or not the campus tour changed students' views about the university, she would randomly split a group of prospective students in half, and she would give one group a tour and one group would not get the tour. And before the tour, there would be a pretest to all of the people to measure their perceptions of the university, and then afterwards, she would administer the same survey to both tours. To both groups. So she would be able to say, okay, so the only reason why anybody's views would change from pre-test to post-test would be because of the tour or the lack of tour. So that would be a true experiment. Okay, so the important thing to take away from this presentation is I really want you to be thinking about your own topics, your own research topics, and thinking about the design you could use to answer your questions. So some of you will have research questions that are quantitative. And so you'll be doing this research and answering your questions using numbers, right? And so what I want you to think about is whether or not, what type of design that I've described here, for those of you who have quantitative research questions, what type of design you might be able to use to answer your own questions. And in class, we will spend time workshopping through different design options for those of you who have quantitative questions, and we'll help one another out to try to think about design ideas that you can propose and study. An important takeaway in general for everyone from this presentation is that really it's a tricky thing to make causal conclusions about relationships, and you really need to have experimental or quasi-experimental designs in place, or otherwise you shouldn't be making any causal conclusions about relationships that you observe. Again, I know that I've kind of slammed through these ideas in this presentation, and I put 2 chapters on Blackboard that cover both of these designs in more detail. So please do read them if you want to know more about these designs, or if anything didn't make sense, we'll have time for questions in class, or again, read through those chapters. Okay?